differentiate cos x to the negative 1 with respect to x. And note that that does not mean the inverse cosine. So I'm going to let y be equal to cos x to the negative 1. And then we'll have to differentiate with the chain rule. So it's going to be negative 1 cos x to the negative 2 multiplied by the differential of the inside. If you differentiate cos, you get negative sine. And so that is sine x cos x to the negative 2, or, if we like, sine x over cos squared x. Hence find dy dx given that y is this. Okay, so dy dx in this case is going to be, well, if we differentiate tan, we get sec squared x. That's one of those ones you can do tan x as a quotient, as sine x over cos x, but it's not that good an idea because you're going to have to then do this by a quotient to get a result that you probably just need to remember. And then from the first part of the question, that is going to be 4 sine x over cos squared x. Using the answer to part 2, the bit that we just got, find the values of x in the range 0 to 2 pi such that dy dx is equal to 4. So in other words, we want to solve sec squared x plus 4 sine x over cos squared x is equal to 4. Okay, so how are we going to go about this? So sec squared we know is 1 over cos squared x. Then we've got 4 sine x over cos squared x equals 4. So let's maybe multiply through by cos squared x, and then we'll have 1 plus 4 sine x is 4 cos squared x. Now I think we can get a quadratic out of that if we remember that sine squared plus cos squared is always 1. And therefore cos squared can be written as 1 minus sine squared. So we've got 1 plus 4 sine x is 4 1 minus sine squared x. So 1 plus 4 sine x is 4, take away 4 sine squared x. So 4 sine squared x plus 4 sine x, and bring the 4 over, take away 3 is equal to 0. Okay, now I think we can factorize this, which is nice. Always nice if we don't have to use the quadratic formula. I think if we go for 2 sine x and 2 sine x, and then go for 3 and 1, and then if we have a plus here, which will give us plus 6 sine x, and then minus there will give minus 2 sine x. So we've got sine x is equal to negative 3 over 2, or sine x is equal to a half. And this one is not possible. Sine would always be between negative 1 and 1. So that one's not possible. So we just got sine x equals a half. We're solving in radians. And sine x equals a half is a standard value. That means the principal value for x is pi by 6. And ASTC, so the first one's there, pi by 6. For a sign which is positive, the other one will be here, pi by 6. And between 0 and 2 pi, our solutions are going to be pi by 6. And then just here, remember pi here is 6 pi by 6, so that one would be take away a pi by 6 from that, which is 5 pi by 6, and then we don't get any more solutions, so we just get those two.